I'm back. I'm going to try to finish this atmosphere section, and I may do another one because I got to keep you busy for the whole time. And yeah, so we're going to finish up this atmosphere. Between the last video and this video, I was looking at the essentials a little bit more. And right here it says analyze the array of climate feedback mechanisms that control the Earth's temperature over time and compare and contrast these feedback mechanisms to those operating on inner planets and the gas giants. And we see some of the key vocabulary over here, like air pressure, sea breeze, stratosphere, thermosphere, trace gases, and so forth. And really, how do we know? How do we know that the atmosphere has changed over time? So I'll try to answer all these questions in this segment. All right, how do we know? How do we know the atmosphere has changed over time? One of the great ways that we can go back a long ways in history or back in time is the ice core samples. And I think they can date back over 1,000,000 years. Each year we get a new year of snowfall. And just like tree rings, we can see where you didn't have as much, and then you go into the snowfall season, and you don't have as much, and you go into another snowfall season, and then like increments like this. Well, that traps information for us. That traps information. It's like what type of gas is in the atmosphere. They can take that small little section and do a chemical analysis of the gas throughout that year period of time. And we can see if carbon dioxide levels have risen or have fallen within that period of time. Over a long period, we can kind of get graphs of it going up and then going down, going up and going down. So that's one way. Another way is tree rings. And I believe that some of the tree rings the trees that we have on Earth can date back a couple thousand years. We can see climate. Like, for example, the settlers that landed on Roanoke Island in North Carolina, I believe. We can get the trees that, I think it's like 1,400, 1,500, over 500 years ago. We can do a tree ring analysis of that area, the climate in that area, and see if it was dry or if it was very, they got a lot of precipitation. One of the theories is that the people who landed on Roanoke Island in North Carolina, that there was an area when they landed, and they were there for that period of time, that it was a drought going on during that time, and that may have led to salination of the water they were consuming, and some of them might have died that way, not knowing they were consuming the hyper salinity or hyper salt laden water, and they're consuming it, and that could have led to some of their death. Anyway, the troposphere, so climate, that's one of the ways we can tell is ice core samples and tree ring samples. Okay, getting into the layers of the atmosphere, I'm going to go ahead and show you some pictures real quick. So layers of the atmosphere. And I'm going to pull up some images. And you can see here these curves and these lines. What's going on, why they are bending like this or why scientists even break these layers up, is because of temperature changes. The lowest level down here, the troposphere, which it says right here, this is where all the weather occurs, the troposphere. And then you go into the stratosphere, and you see the plains. Let me make this a little bit bigger for you. All right, you see the plains. The planes try to fly a little bit above the troposphere, but below the ozone layer, because they want to get above the troposphere, because that's where all the weather is. So they get above it, it's a little bit, it's not quite as bumpy. They get above all the turbulence, but they don't want to go up here because then you're not protected. The ozone layer protects us from the UV radiation, and the ozone layer is inside the stratosphere. So you get the troposphere where all the weather occurs, and then you go into the stratosphere where you have the ozone layer. And if you look right here, when you get to the stratosphere, it kind of warms up a little bit right there, doesn't it? That's because the ozone layer, the O3, traps heat, and yeah, that's what's going on there. So when you get up here to the mesosphere, this is where the meteors burn up at, and it gets a lot colder. This is like your coldest layer. This is where meteors start to come down, and you see that right here, where they start catching on fire. And hopefully by the time they get there to the bottom, they've actually burned up and they're dead. They're gone now. If they do hit, that's called a meteorite. But you see up here, it's a meteor. Meteors was when they come into our atmosphere. A meteoroid's just one that's kind of floating in outer space. But if they come into our atmosphere, it's a meteor. If it hits the ground, it's a meteorite. So the mesosphere is right here. What's up above it is the thermosphere, and the thermosphere is actually divided into other layers too, but you don't need to know that. Just know that this is where the ionosphere occurs. They do have more layers, but like the ionosphere, the exosphere, and so forth. But just know this is where the northern lights occur. The gas molecules up here are moving really, really, really fast. So, and that relates to temperature. So high temperature, but you'd have low heat because there's hardly any air molecules there. They're so spread out. They're so spread out because gravity has pulled them down. Gravity has pulled the air molecules down, and they're down here. Up here, it's hardly any air molecules. But since they're so far away and they're closer to the sun, and they're receiving that energy from the sun, they're like, pew, 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 and they're all over the place. So high temperature but low heat. So these are the layers of these are the layers of the atmosphere right here. Remember, the ozone is nothing but O3. All right, let me see. I'll go back over here, and I'm going to show you that. So you just talk about the Roanoke Island, North Carolina. Settlers. Settlers. And okay, this is the Roanoke Colony. We do Roanoke Colony and tree rings. Colony, tree rings. And of course, we did the tree carving. Yeah, there it is. Drought may have doomed the lost colony. And this is the New York Times, 1988. And hit this picture right here. I don't know if this is in correlation to what I was talking about, but this does show rings, and the amount of the amount of precipitation would result. If you have lots of precipitation, you have a thicker ring. If you don't have that much precipitation at all, you would have a very thin ring. And here's a great picture. Let me pull this picture up. All right, I'll magnify it a little bit. All right, man, it goes back to 1531. And you can see Jamestown drought in this area right here. The rings are a little bit closer together, so you have a drought going on. The Lost Colony drought, I guess right through there. Not sure. But yeah, that's a theory. And you see lots of water there in that area, lots of precipitation this year. Anyway, that's a theory. That the kind of cool, right? It's a theory that they were drinking water that was laden with salt. And how do we know that? We know it from tree rings. That's pretty cool. So we can look back and see climate through these different methods, ice core samples and tree rings. Let me go back over here to the pacing guide, or the essential knowledge. Thermosphere, stratosphere, sea breeze. A sea breeze is nothing but unequal heating of the land, the beach area, compared to the ocean area. And during the day, the land heats up more, so you have a low pressure there, and it's colder in the ocean, so it's high pressure. And high pressure goes to low pressure, so you have a breeze coming off the ocean. That's called a sea breeze. And at nighttime, it's just reversed. The land cools quicker. The water is still warm because water is a great heat absorber, so the water is warm. So now the water has low air pressure, and high air pressure, and the land has a low air pressure. So you have water going from the land to the ocean.